so I was driving like 70, and this cat came out of nowhere, and I just stepped on the gas and freaking. Oh, hi, didn't see you there. Hi, my name is Chris Bollinger.
And my name is Karl.
And this is Chemistry with Chris and Karl. Today's lesson is the history of chemistry.
Let's start where it all began. Scientists say that the first controlled chemical reaction was fire, or combustion of wood. This would have taken place in roughly 40,000 BC. It's a long time ago. This would have taken place in roughly 40,000 BC. It's a long time ago.
The earliest metal recorded to be used by humans is gold. However, bronze became much more practical, and the Bronze Age came about in about 5,500 BC.
Our ancestors discovered ways to combine the elements tin, lead, and copper to create bronze. This process was one of the first instances of chemical experimentation.
A little bit later down the line, a nation of people known as the Hittites figured out how to extract the usable metal from the element iron, furthering chemical experiments of the time. The Iron Age began in about roughly 1200 BC.
It was during the Iron Age that official chemical descriptions were assigned to different chemicals. The terms solid, liquid, and gas, when referring to the state of a substance, came into play. Ancient scientists also used descriptions such as color, scent, and density to distinguish chemicals.
In Greece, around the same time, the use of the term elements became popular. There are many elements that we know exist today, but the first to be conceived were fire, earth, water, and air. Little did they know that none of these were actually elements at all.
So, let's take a large time skip here to the time of the Middle Ages. Many technological advancements were made through the field of alchemy, which was essentially the early days of chemistry.
The alchemist Jabir bin Hayyan began chemical experiments with sulfur, mercury, iron, and many others.
More strictly, alchemy is defined by the search of scientists for the formula for a philosopher's stone, a catalyst believed to have the ability to turn any substance to gold and to make the user immortal.
Obviously, this goal was far-fetched, but the search gave way to many scientific breakthroughs, including more chemical experiments.
Fast forward to the Renaissance. Sir Francis Bacon outlines an efficient method to outline scientific procedures, experiments, and results. He aptly calls it the scientific method.
Later in the 1600s, Robert Boyle discovered multiple properties and methods of calculation involving gaseous substances. This is where Boyle's law comes from. His law describes the relationship between volume and pressure.
In the 1700s, a chemist named George Stahl termed two substances involved in combustions in fire: oxygen and floxygen. Turns out floxygen isn't a thing, but rather just the flame. The discovery of oxygen, however, is incredibly vital to current chemistry.
In the late 1700s, a guy named Alessandro Volta established the study of electrochemistry, the study of electrical currents through chemicals and such.
Around that time, chemist Antoine Lavoisier developed multiple chemical achievements, the most important of which is the law of the conservation of mass. In addition, he developed some of the first organized chemical nomenclature, which describes today how we name chemicals.
He was the first to develop a table of elements, which included oxygen, nitrogen, hydrogen, phosphorus, mercury, zinc, and sulfur. Boom.
A chemist named John Dalton several years later proposed his own chemical law, named Dalton's Law. Surprise. It describes the relationship between the components in a mixture of gases and the relative pressure each contributes to that of the overall mixture.
In addition, Dalton developed his atomic theory, which defined particles that made up everything. He called these atoms.
Since we're running out of time, we're going to skip forward in time. During this time skip, Hess's law, chemical bonds, Mendel's periodic table emerged, all of which, as you know, are in full effect today.
Throughout the 19th and early 20th century, more and more elements were being discovered. Noble gases were discovered, as were radioactive isotopes and their uses. Scientist Ernest Rutherford described radioactive chemical decay, defining the term half-life.
Chemist Niels Bohr theorized subatomic particle placement, explained that negative electrons fill different shells surrounding the positive proton and the neutron nucleus in every atom. Close enough. Yes.
Wow. And up to this day, countless advancements in biochemistry, electrochemistry, and just about every subdivision in chemistry.
Chemistry.
advancements have pushed for a future understanding of the chemical field.
Unfortunately, we could not include all of these discoveries and inventions in our talk today, but you can find them in your textbook or online on alexweber.tk.
Yeah, probably not on Outlook.tk, but thank you for joining us today. It's a shame you couldn't stay longer.
Join us next time on
Chemistry with Chris and Karl and Jack and Alex.
At alexweber.tk.
All right, anyway, we good?
Yeah, we're good.